Okay, we're continuing with the part two of chapter 11 of conceptual physics. We're going to discuss the atomic structure. Every atom includes the following: an atomic nucleus, which is comprised of nucleons, protons, which are protons and neutrons. Protons are positively charged, neutrons are electrically neutral. Protons and neutrons are comprised of quarks. We'll see that in detail in a little bit. And they're held together by the strong nuclear force. The strong nuclear force, if you can think of magnets, if you have um, a north pole of a magnet and a south pole of a magnet, if you bring them together, they attract. If you have a north pole and a north pole and you try to bring them together, they repel. Well, it's the same thing with protons and electrons. A proton and an electron attract each other. A proton and a proton repel each other. Yet in a nucleus, you have many protons held together, and it's the strong nuclear force that holds them together. That is the strongest force that we have, gravitation being the weakest force. There's four fundamental forces: the strong nuclear force, the weak nuclear force, the electromagnetic force, and gravity. And gravity is the weakest of those. I think we mentioned that in the past. Okay, electrons. The nucleus is surrounded by a cloud of electrons. Don't think of the old orbiting electrons like a solar system. That's the old model. Now they're in a probability cloud. You can never really know where the electron is, but you'll know there's a great probability that it'll be somewhere in this cloud. Electrons are negatively charged, and electrons are electrically bound to the nucleus. Electrons and protons are in equal numbers. So if you have 6 protons, you're going to have 6 electrons. If you don't, then you have an ion, and we'll discuss that later. Okay. I think I'll dismiss my image. Okay. Here is a kind of a blow up of the structure of the atom, and you'll see that you have a proton is made of an up down quark. A neutron is a down down up quark. Now you don't have to know this. This is just for general information. This is the nucleus of an atom, and the main reason why I'm showing this is this little caption down here, so that we can get an idea of the scale. If the proton and neutrons in this picture were 10 centimeters across, then the quarks and electrons would be less than 0.1 millimeters in size, and the entire atom would be about 10 kilometers across. So the outer shell, if you want, of the electron cloud would be 10 kilometers across. Another way I've heard it recently, that if you were to take the nucleus the size of a tennis ball, the electron would be about 1 mile away. So there's a lot of empty space in the atom. In the tennis ball and the 1 mile away, that was for a hydrogen atom, which only has 1 proton and 1 electron. Okay, let's look at here's a simplified model. Simplified model of the atom consists of a nucleus surrounded by electrons in shells. Now the shells become smaller with more shells. As you start, you can see here you have a hydrogen. It's got 1 shell. When you have 2 electrons in the shell, it gets smaller. And then you have lithium. There's the nucleus. There's the shell with 2 electrons. And then you have this other shell. Then you take aluminum, 13 electrons and 3 shells. And you can see how I think they're showing you relative size, so you can see that the yellow shell is greatly reduced and the blue shell is reduced from what it was here. Then you have this green shell. And we'll see relative sizes in an upcoming slide. Okay. Elemental substance, each composed of only 1 kind of atom. The lightest and most abundant in the universe is hydrogen. Hydrogen has 1 proton in one electron. It can have no neutrons. It can have one neutron. It can have two neutrons. I think there's even some with three neutrons. They're rarer, but it can happen. At present, there are 118 elements that are known. 90 occur in nature. Others are produced in the laboratory, are very unstable. They only live for a very short time, and they break down. The words atom and element can be used interchangeably. Each element shares the name with its atom. Composition of living things include these 5 elements: oxygen, carbon, hydrogen, nitrogen, and calcium. So those are the 5 elements that make up the composition of living things. Okay. The periodic table. The periodic table is a chart. It's a chemist's roadmap of the elements arranged by atomic number. The atomic number is equal to a number of protons in the nucleus. It's arranged from left to right and top to bottom. Successive entries have one more proton and one more electron than the preceding entry. In the rightmost column, outer shells are filled to capacity, known as noble gases. And so this here, the helium, neon, argon, krypton, xenon, radon, they have their shells full, and so they don't accept electrons, and they don't lose electrons. Over here, you always have on the outer shell, you always have an extra electron. So here you have sodium. It very easily becomes a sodium ion, so that it's always going to have 11 protons, but it might have 10 electrons. And over here, in chlorine, it's 17. To be completely full, it would have 18. So it's ready to accept an electron. So guess what? You have a you have the sodium atom will give up one of its electrons, and it'll go on to the chlorine atom, and you get sodium chloride, and you get this ionic bond between the sodium and the chloride. Anyway, that's just an example of how these shells are how they are used in chemistry. Okay, and here's we go back to this. It's got a lot of jargon in there, and this is the key. This one here is the key. This is the atomic number, the symbol, the name, the abridged standard, and the atomic weight. So the carbon has 6 protons. So, and that's the name, carbon, or that's the symbol. That's its name, carbon, and it's the atomic weight is 12 point. The abridged standard atomic weight. I think I said that wrong. That's not 2 things. That's just 1 thing. Abridged standard atomic weight, and it's 12.011. So most cases, it's got 6 protons, 6 neutrons, and 6 electrons. Now there's a 0.011. It's not exactly 12. That means that there are occasions that there's more than 6 neutrons. You might have 7 neutrons. You might have 8, but those are rarer. And now gold is 79. This is the symbol AU for gold, the name, and it has a combined proton and neutrons of 196.97. That's almost 197. So the most abundant isotope has 197 combined protons and neutrons, and we'll get to that. We'll get to isotopes a little bit later. And let's go. The diameters of the outer shells are determined by the amount of electrical charge in the nucleus. Gradually decrease from left to right across the periodic table. As the nuclear charge increases and electrons are added to the outer orbits, the inner orbits shrink. And we can see that here. As you keep adding, you see this one only has one electron in its orbit, and as you keep adding electrons, it shrinks on this particular row. I think I showed that in the one with the colorful models of the elements. Okay, and that's the end of part 2.